Hello, everyone. In this video, I am going to go over the common fate moderation model using the product indicator approach. And so this video is associated with the article entitled Estimating Dyad Level Processes in MFT Research, General Overview of the Common Fate Model and Extensions to Mediation, Moderation, Growth, and Hybrid Models published in the Journal of Marital and Family Therapy. So this is one of three common fate moderation approaches that I talk about in the article. And here I'm going to demonstrate how to estimate the product indicator approach to test moderation among latent variables. Before jumping in, I'll actually show you a picture of or a diagram or a figure of the common fate moderation model. And so through latent moderated structural equations, which I go over in other videos, this approach to moderation is actually a little bit different. These are estimated in different ways, although they will provide similar or identical solutions. But what we are doing in the product indicator approach, unlike latent moderated structural equations, is we're going to estimate the latent variable and we're going to create the interaction terms among the four possible interaction terms from dyad member 1 and 2. And then we're going to use those as indicators of that latent variable, right? And then what we're going to do also is to correlate the residuals or the errors on each of these observed indicators. So in latent moderated structural equations, these covariances are not there. And it's not depicted in the figure. The interaction term is not covaried with the main effect as well as the moderating latent variable. But we will see in the product indicator approach, we will be doing that. All right. So there are going to be some different ways that we are going to specify this approach. All right. So now we can again move over into M plus. All right, so this is the same syntax file that have been used in the other demonstrations. And so if you are interested in getting started or unfamiliar with M plus or these syntax or these variables, you can go back to the video that covers the baseline common fate model. And I provide a little bit more of an introduction to the different types of variables that we're going to be using. Right? So what we're going to do is we're going to skip down to the define command first, right? So in other ways of testing latent interactions using Bayesian or maximum likelihood, we use latent moderated structural equations. And we just use that X with statement and we define the interaction term in the model statement. But when we use the product indicator approach, which is kind of more analogous to the traditional ways of testing moderation, particularly within like the general linear model, where you're multiplying your independent variable and your moderating variable together to form the interaction term, we're going to do that here. All right. So what we're first going to do is we're going to create those centered variables. And so this is actually what we're going to be doing is actually going to be called double mean centering. Right. And so this is talked about in an article by Lin et al. In 2010. And so what we're going to do is we're going to obtain the sample means for each of our six variables, right? So for dyadic coping, couple satisfaction index, and relationship mindfulness. Theoretically, you don't need to do that with CSI, but I'm just going to center all of the variables, right? And so what we're going to do here is we're subtracting the common dyadic coping subscale for women. We're doing the observed variable minus the mean, right? So that's centering. And we're doing that for the males as well. And then we're doing that for relationship quality for the males and females. And then we are doing that for relationship mindfulness in general. So the reason that we center our variables is that it can aid in interpretation, right? So the interpretation changes from kind of, a 1 unit increase on the scale, which often or actually may or may not have, a legitimate kind of realistic or substantive interpretation. Oftentimes the metrics are arbitrary, like a 1 to 5 Likert scale. Um, and it shifts then to, 1 unit above the mean, right? So we are shifting the focus to the scale to now the sample mean. Right. And the reason we do that within moderation, and the reason we engage in this linear transformation is it helps reduce multicollinearity. And oftentimes it can actually allow the intercept to take on a more meaningful value. All right. In structural equation modeling, that's not always the case. We don't really look at means and intercepts all that much, but particularly if you're using like just traditional like multiple regression techniques, that intercept term may become more meaningful depending on your variables by centering, right? And so the primary benefit of centering is it reduces multicollinearity. And what we're doing when testing interactions, when testing moderation, is we're intentionally baking in multicollinearity through the creation of the products, right? Through that interaction term. And so you might hear people talk about, collinearity is a major problem. Well, in moderation, we actually think it's kind of a good thing because that's actually how we're getting our interaction term. That's actually how we're testing our hypothesis. So collinearity in and of itself is not a bad thing in any way, shape, and form. And again, here it's even necessary. But what will happen is when we have values that are of multicollinearity that are too high, that means our two variables at least, are providing redundant information, and one is not providing any new information. And so when we actually go to invert our matrices in structural equation modeling, we have some problems in that because we have some problems in our eigenvalues and our eigenvectors. But again, that's for a deeper discussion within structural equation modeling. But essentially, the matrix multiplication kind of collapses in and of itself because there's no new information being provided by one of the predictors. It's completely redundant with another predictor. Right? And so that is what we are going to attempt to eliminate here. All right. And so that's why we are centering all of these terms. All right. And so we're going to create these centered terms. And then we're going to multiply those centered terms times one another. All right. So for this, in this example, we have heterosexual couples. And so all the variables with an underscore M, those are the male partner. And if they don't have an underscore M behind the variable label, then they are female. And so we have the centered male relationship mindfulness times centered male common dyadic coping. And then we just create each of those, the 4 possible interaction terms. Okay. And then, because we're using double mean centered methods, we are going to center again. And this is just another way of centering. Here, I just showed you actually going into the sample values and just obtaining those means by on your own. But M plus, you can type in grand mean to grand mean center the interaction terms. And again, you'll see int1 dash int4, that's telling M plus int1, int2, int3, and int4, right? So it's a shortcut in the syntax. So I am now double mean centering those interaction terms again to get rid of any unnecessary multicollinearity that might present some convergence problems, right? And so in the use variables command, again, in contrast to the other ways of testing moderation with latent variables, we actually need to specify the interaction terms up here. Traditionally in LMS, we specify the interaction term in the model statement, and we don't need to do anything in the use variables or define sections, but in this case, we do. All right. And so we're going to use maximum likelihood estimation. And then this is specified in the identical way to other ways of testing moderation. Here is where there is a slight difference. Here is where we are, specifying the interaction term manually. All right. And we are actually defining the interaction term between relationship mindfulness and dyadic coping by the 4 interaction terms here. Right. And again, congruent with the picture or the image that I showed you, we're going to correlate the errors of those interaction terms. All right. And so again, this is a shorthand way to do to do that rather than typing out, int one with int two, int three, and int four, and then doing int two with int three, int four. Again, this is a much shorter way of doing that where we are just covariating everything with everything. Right? And then what we're going to do is, actually, I need to add back in the int term here. We're going to have the couple satisfaction index, our outcome variable, being predicted by the main effect of our independent variable, our moderator, and our interaction term. And then we are going to covary the interaction term with relationship mindfulness and dyadic coping, the main effects, and the values of the moderator. All right. And then here we have the residuals as we would in any common fate model. So what we're going to do from here is we're going to actually go ahead and we can run this. And so we'll run this, we'll scroll down, and we run into an error message. And so the standard errors for H1 our estimate cannot be computed. This may be due to low covariance coverage. This is not the case in our sample. I think M plus will still provide covariance coverage. So we have, I think at lowest, looks like 98.7% covariance coverage, which means that 98% of the sample of men provided information on the real relationship mindfulness and the two variables that go into int4, whatever they may be. So again, we have a missing data rate of around 1.3% at most. So that's clearly not the problem here. All right. So no convergence, number of iterations exceeded. Essentially, we ran into some pretty significant problems here. Our model didn't even converge. We got estimates. We are still able to generate our estimates, but we can't generate our standard errors or our test statistics, right? So there's a couple of things that we can do. But I know in moderation analyses, again, I know that multicollinearity is something we need to be thinking about. And ultimately, this is really the only way it'll influence your results. It won't change a significant result to a non-significant result because it's a linear transformation. So you're just moving the X or the Y axis and changing the interpretation of it. You're not actually doing anything different to the data. But this is where we might actually have multicollinearity. So I'm actually going to check that out. And so one of the ways in which I will look into multicollinearity is I'm actually going to remove this latent interaction term here. Okay, so I want to remove that from the model. And you can use the exclamation point in M+, and it tells M+ to skip over. All right. And I'm actually going to rerun the model. So this is kind of a nuisance model. So I'm not interested in the parameter estimate. I'm not really interested in model data fit. I'm not interested in any of those things. What I'm really going to do here is I'm going to be looking for multicollinearity. So I'll go ahead and run this. All right, so we get an error message. All right. And so, again, this is one that we can actually kind of ignore. So the model did terminate normally. So this would be an improper solution because, again, M plus is telling you there's something going on, but that's actually not really what I'm interested in. What I'm interested in is the correlations among the interaction terms. So this is really why I'm running that model, right? And you could run this completely separately if you wanted to. But since the model converged, I just ran it in this model rather than creating a whole new syntax file. And so what immediately jumps out to me is that we have a correlation of 0.998 between interaction 1 and 2, all right? And we have a correlation of 0.998 between interaction 3 and 4. So this is where we have a legitimate case of multicollinearity. In my experience in running the common fate model is I always use latent moderated structural equations because of this issue. And the reason it might be more salient in dyadic data is if we think about kind of what we're doing in the general ideas of dyadic data is we're baking in multicollinearity intentionally just in moderation analysis. But because we have dyadic data, because members' scores are correlated, their residuals are correlated. They're more highly related than a set of two independent variables within like the same person, for example. So an example would be my reports of dyadic coping and then my partner's reports of dyadic coping. There's going to be a higher correlation between that than my reports of dyadic coping and my reports of depression or stress or whatever it might be. So in dyadic data, there's an additional level of interdependence among the interaction terms beyond what we're just testing in moderation. And so that is most likely what is happening and why we're not getting a converged solution. So with the common fate model, I tend to again just skip over this product indicator approach because latent moderated structural equations is easily usable within M plus. But if you're not an M plus user and you're here more to just understand kind of what the product indicator is, and you're using SAS or Lavon or something, some of those other programs, this is the way you are actually going to have to test moderation. And so it's something to consider when testing those hypotheses, that it is often that you will get a non-converged solution because again, there's so much levels of multicollinearity here due to moderation and dyadic data, right? And so essentially what this means is we most likely cannot run this model. I think even if we change the convergence criteria and made it more liberal, um, these two correlations are still going to be way, way, way too high in order to provide any unique information. All right. So essentially, what this means is interaction one and interaction two share probably roughly 97% of the variance. All right. So we just square this correlation here, and that's the amount of variance that is shared between the two. And it's going to be, 97, 98%, 99% even. And that's, again, providing almost exclusively redundant information. Right. So this is where, if you are an M plus user, I would move straight over into latent moderated structural equations, or potentially if you're a Lavon user or in SAS or in these other SEM programs and Amos even, I would move into M plus and see if you can do it that way. I don't believe the M plus demo version would allow these types of analyses because they place restrictions on the number of variables that you can have. So it may be beneficial if you're looking into running common fate moderation model to obtain a copy of M plus. Again, at the time of this recording, no other statistical program can feature latent interactions, and you actually are restricted to this product indicator approach. Right? So again, hopefully this video has been helpful in walking through kind of the estimation procedures of the common fate model with the product indicator approach. Again, using the double mean centering method talked about by Lin in 2010. Thanks so much for stopping by.